Okay, before we get into the addition and subtraction of integers, I want to address something. It's something that I call the sine-sign phenomenon. You're not going to see it in textbooks. It's kind of a Mr. Vizza-ism, but it is something that if we address it, it can help improve your reading and writing, which I think is really at the core of bringing up our uh, our basic level as we get ready for algebra. So let's take a look here. Sine-sign phenomenon. Let's just say that it's by definition, working definition, it's two math operations or symbols in a row, not separated by numbers or variables. Now, an example of that would be something like this, where we get 3 minus negative 4. Okay, and you see here we've got the minus and the negative not separated by any numbers between them. Similarly, you could get something like 4 plus negative 3. And again, that's where we have two signs in a row. Okay, one is actually an operation, the other is a sign. Plus is an operation, negative is a sign. Okay, so here we go. Non-examples would be something like this. Now, this is one that people tend to get wrong, where they have negative 4 minus 7. They go, oh, I see two signs. I see two negative signs. Well, what we have here is, although we have two symbols or operations here, they are in fact separated by a number. Okay, so that is a non-example. Okay, now let's talk about a word about sine-sign phenomenon. It's not wrong to write things like this. It's not incorrect mathematically. Okay? However, as you transfer over to algebra, this style of writing is going to be a hindrance. Okay? So we want to be able to rewrite this expression in a way that does not have these two symbols in a row. That's what we're going to take a look at doing. Again, it's not incorrect or false to do it. It's just going to be a hindrance as you develop as an algebra writer and reader. Okay? So let's take a look, for instance, here by trying to identify it. So here we have, please identify which of the following expressions exhibit the sine-sign phenomenon. Well, if we look here at number 1, it says 2 plus negative 4. That's a situation where we have these two these two symbols. One's an operation, one's a sign, okay, in a row. So this does exhibit the sine-sign phenomenon. Number 2, 5 minus negative 7. Pretty much the same phenomenon. You get an operation followed by a sign, so that's going to be the sine-sign phenomenon. In number 3, where it says negative 2 minus 8, this is not the sine-sign phenomenon because there's not two consecutive symbols. Okay, consecutive means in a row. Okay, there are two minus signs, or minus looking signs, but they're separated by the 2. So in number 4, similarly, not a sine-sign problem because they're not two in a row in terms of signs or symbols. In number 5, we see 12 minus negative 4, so that in fact is a sine-sign problem. Okay? We haven't done anything with these yet. We're not simplifying them or rewriting. We're just talking about identifying right now. You need to be able to know what one of these expressions looks like if we're going to work on it. So here in number 6, we have the opposite of negative 2 plus negative 1. Well, this is a sine-sign phenomenon twice. Here you've got the opposite of a negative and plus a negative. So that is definitely going to be the sine-sign phenomenon. Okay, now let's talk about how we can manipulate the sine-sign phenomenon to our advantage. Okay. First, we need to take a look at some concepts here. They're a little bit abstract, but I think these will make sense once we go through them. We want to talk about things that are equivalent expressions, okay? Because if we're going to rewrite them without this, if we have a sine-sine problem, and then we're going to rewrite it so that it's not a sine-sine problem, they still have to be equal. You can't just change the value of things in math randomly. So let's take a look at how this will go, okay? John found a gift certificate for iTunes. Now, it doesn't sound very mathematical, but let's try and maybe connect it to something that might be. I would venture to say that found might be a plus, and a gift certificate might be a good thing, so let's just call that it's a positive, okay? Now, in this next one, we have John's doctor removed a cyst from his kidney. Doesn't seem like math, again, but let's try and connect it to maybe a mathematical notion. John's doctor removed. Removed sounds like minus. And assist doesn't sound like a good thing. It sounds like a negative thing. Okay? Now, if we notice here, we have that both of these things are good. Okay? Well, we might say, well, getting a cyst removed doesn't sound good. Well, if it's not supposed to be there and you get it out, I think it's good. So we see that adding a positive is a similar effect in that it's good to subtracting a negative. So again, we want to see that there's a relationship between these two things, adding a positive and subtracting a negative, because they both sound pretty good to me when you think about it. Now let's take a look down here at these statements. It says, John lost his strength from not exercising. Well, not a lot to convince you probably that lost is minus and strength is a positive. Okay? So that's pretty straightforward, I think. John got a cold last week. Well, got sounds like an add. Okay, something got added to him. And a cold, well, that doesn't sound too good to me. That sounds like a negative. Okay? Now, if we see, like, losing your strength and getting a cold, I'd have to say that both of these are bad things. Okay? So if we notice here, there's probably some type of relationship between subtracting a positive and adding a negative. Okay? And these will help us, these two relationships will help us rewrite things without the sine-sine phenomenon. Okay? So, let's continue on. Okay. So if we're going to rewrite the following expressions in a way that eliminates the sine-sine phenomenon, let's take a look at number 1. 2 plus negative 4. Well, this sounds like you're getting something bad. It's going to be 2 plus negative 4. Well, I think that would be very similar to just subtracting 4, because you're losing something good. Now, if you notice here, the one thing that's not written in this statement is a little plus sign right here. Okay? Do you see where we have now? It's a little more clear if you see that adding a negative and subtracting a positive are equivalent ideas. But if you notice, I don't have to write the positive sign. So now, I go from 2 plus negative 4 to 2 minus 4. It's a little easier to read. It doesn't have two signs in a row. It's only got one sign, if you notice it, that you can see. And then it even drops the parentheses. Okay, so in number 2, where it says 5 minus negative 7. Well, minus to me sounds like you're losing something, and negative sounds like something bad. So if you lost something bad, that would be a good thing. So I think that you could equate that to just addition of a positive. 5 plus 7. And again, we're not writing that little positive sign that we go right about here. And now we've gone from 2 signs to 1 again. Similarly here in number 3, where it says 12 minus negative 4, minuses lose, negative is bad. So if you lose something negative, that sounds pretty good. So I think that's going to be 12 plus positive 4. I didn't have to write that little positive sign because we don't tend to write them. So in number 4, where it says the opposite of negative 2 plus negative 1, well, the opposite of a negative is pretty straightforward. It's just a positive. And plus a negative here, well, plus it sounds like you're getting something. Negative sounds like it's a bad thing. So if you got a bad thing, it would be kind of similar to losing a good thing. So instead of adding 1, it would be minusing 1. So if you notice here, all of these rewritings that I've done, they're more straightforward math problems. Now the one thing you want to realize is that the ones we started with, they're not wrong. They are in fact equivalent to the ones that I wrote. Okay? But the ones that I have highlighted here, they're a little easier to comprehend. And they become really important for some other things we're going to do in algebra when we get solving equations and applying inverse operations. So we'll hold on to that for now. So this is going to take a little practice getting used to this rewriting idea. But it comes around pretty quickly. And it's really going to help us immediately when we go to simplify problems where we need to add and subtract integers.